Now we would be looking onto the conditional expressions. So what does this say? A conditional expression selects between two expressions according to the value of this condition. So let's see here what this says, the logic says here. Now the syntax is as shown here. The condition, if it is true, it would take the expression once, else it would take the expression 2. And shown here is an example of a particular module here, conditional expression, where these start xm and then the shift val, reset, stop xm, all these are the parameters. The input xm and then shift val, reset are taken, and then the output is the stop xm. So we would be seeing whether if the reset not reset condition holds, and that is if it is true, it would be going to the shift val,
exactly,
right?
exactly.
And else it would be going to the next one. So what is it important to understand for our viewers to understand the logic here from the conditional expression?
Yeah, it is the same as we've been discussed earlier. Earlier we use the same conditional expression. What we obtain is an inverter. Now what we are obtaining after synthesizing is a ordinary combinational block, which is technology dependent. So here if the reset is 0, the start x would be XOR of shift val, or if the reset is 1, it would be having start x would be OR of shift val. So here both would be there. Here XOR is there and an OR would be there. Both is there. So this is the hardware which we obtain from a conditional expression.
And that is what is important. And sensitivity list.
Yep, in this example what we are seeing here is a complete sensitivity list. Its output is 0, input is A and B. If there is any change in the input A and B, the output 0 would be A and B. So the pre and post synthesis simulation would both simulate the two input NAND and gate.
Okay.
Okay, one question is there.
So we have another question. Yes.
Yes. Suppose here we can see that all input are present in this sensitivity. Okay.
Yes.
Suppose I deleting the B, what happened?
Yeah, good question. See, if you want to include a B in this sensitivity list, what happens? There would be an error in the design. This procedural block would be working only if there is a change in A or B. Suppose the statement which is underneath the always statement is 0, which is equal to A and B. So what happens if B is not there? So if there is any change in B, suppose A, B are 0 and 1, so the output would be 1. Sorry, it would be 0. But if you won't put B and if you give B as 1, still you will be having an output of 0, even though you have 1 AND gate. Since you didn't listed the B in the sensitivity list, the output would be 0, which is the previous output. So that would be an error in your design.
Okay, you told that I am deleting the B, then the output will be an unknown value.
Yeah, exactly. It would be an unknown value all the time, but most of the time it with the previous value. It depends upon the simulator, and the simulator you don't know which. It's all dependent on the simulator which you are using.
And one more thing is there, always and initial are 0 simulation.
Yeah, that's a very good question. See, initial and always both executes at 0 simulation time, right? But initial executes at 0 simulation time, but it executes only once. It won't execute all the time. Suppose you have written an initial statement, it would execute and come back after execution. It won't repeat again and again if there are any change in A and B. Also, initial is not synthesizable, whereas always is synthesizable.
Here I think we can see that this code is a good example